Hello everyone, how are you? My name is Reza Rahman. In my day job, I'm Principal Program Manager for Java on Azure at Microsoft. Today though, really I'm not here for my day job. I'm really on behalf of the Jakarta E ambassadors. In fact, as you can see, I'm wearing a Jakarta E branded shirt. My screen and my slide deck is also Jakarta E branded. And in fact, today I'm going to be talking a bit about a project that I lead that is very closely related to the EE4J umbrella projects. In fact, it is part of the EE4J umbrella projects. And it is closely related to Jakarta E as a technology as well. On screen, you'll see my contact information. So if you have any questions about any of this later on, please do feel free to reach out to me, and certainly I'll try my best to help you. So the title of the talk, as you can see, is Applied Domain-Driven Design Blueprints for Jakarta E. This is, in a sense, a talk about Eclipse Cargo Tracker. So I'll give you a little bit of a background of what Eclipse Cargo Tracker is and what we're trying to do and how it relates to DDD, or Domain-Driven Design. So this all goes back quite a few years, actually, about 25 years to be exact. Hopefully some of you still remember the J2E blueprints, or so-called the Java Pet Store. So if back in those days, server-side development in Java was actually pretty chaotic. In fact, server-side development in general was fairly chaotic. Everybody sort of did their own thing. Every single project that you would look at, you would use different design patterns and would look completely different from each other. All that changed essentially with the J2E blueprints and Java Pet Store. What this project did was define a set of design patterns and architectural blueprints that all server-side projects that use J2E as a technology should follow. And in fact, it really brought a lot of order into server-side architecture back in the day. Of course, just like J2E, the J2E blueprints has had its own set of problems. But in reality, this has been very profoundly impactful. So even today, if you think about things like DTOs or DAOs or session facade or remote proxy, or any of those design patterns that you likely are using in your projects today, those most likely originated in the Pet Store. But the issue with the Pet Store was essentially the same issue as existed in J2E, namely what is known today as anemic domain models. So you really, at your domain model layer, you couldn't apply object orientation very, very well, because primarily J2E as a technology only allowed you to model more or less the data. So it would be almost a mirror image of whatever you had in your relational database, but you couldn't really do a very rich domain model, and certainly you couldn't mix in behavior and state in your domain model very, very well. So a response to that really was this thing, domain-driven design. And domain-driven design by no means is that new either. But really what it did was it said, okay, your domain models should not be anemic. They should be rich domain models that model essentially your real-world application as closely as possible. The whole reason why you should be using object-oriented development in the first place. And it was relatively popular, and it still continues to grow its adoption in terms of various technology sets and various frameworks. Now, I had been an early adopter of domain-driven design and also an early adopter of J2EE and subsequently Java EE and Jakarta EE. So unlike J2EE, Jakarta EE does actually map to domain-driven design relatively well. First and foremost, because you can create rich domain models. But second of all, Java EE also makes, Jakarta EE also makes a philosophical distinction between infrastructure and code. So your idea is that you should really just be focused on writing your business domain level code and leave the infrastructure level stuff primarily as annotations or specialized APIs. So that's why Jakarta EE fits the domain-driven model philosophy and way of doing things extremely well. So that is really what the Cargo Tracker project is fundamentally about. It is about showing you how you apply these domain-driven design concepts well into a Jakarta EE application. And it is an open source project. It is part of the E for J Umbrella, as I mentioned, and it is at the Eclipse Foundation. I help lead it with a few other folks. It is completely a community-driven project. So before we go any further, I think there is value to explaining domain-driven design and spending some time talking about domain-driven design. So in this talk, we'll talk the primers of what domain-driven design is, why you should consider it, and then we'll talk about how to map domain-driven design in general into Jakarta E applications, and then we'll take Cargo Tracker as a specific example and see how it does what it is aimed to be doing, namely showing you how to apply domain-driven design in the context of this specific technology. So, what is domain-driven design? In essence, domain-driven design is exactly what its name states it should be. So basically, it is about modeling your software as closely as possible to the real-world domain that you are supposed to be implementing. In fact, the nirvana of domain-driven design is that basically, if you were to show a UML design diagram or architecture diagram of your application to an end user, they should understand what this application is doing, because everything from the object model itself, the naming, the variable naming, everything should reflect what it is in the real world. So that is fundamentally the philosophy of domain-driven design. Now, in order to do that, it basically employs a set of architectural paradigms and design patterns. And the fundamental design patterns are just a few. They're not very large in number. And these basically form the fundamental building blocks of what domain-driven design is supposed to be. So this diagram that you see on screen now is actually not something I have formulated. This is a diagram that is there, and it's well understood in the domain-driven design community. And they basically encapsulate the building blocks of domain-driven design and some of the key design patterns that exist there. So we'll take a look at these design patterns first and do a quick tour of them, and that will give us actually a pretty good understanding of how to apply domain-driven design in real life. So let's start with some of these design patterns. One of the most fundamentally important ones is the entity. In fact, at the heart of it, this is really what makes domain-driven design really what it is. So as the name implies, an entity is an important thing in your business domain. Most of the things in the real world are really things. These are nouns of various kinds. So in terms of Cargo Tracker, the Cargo Tracker application, as its name implies, is basically about tracking cargo across the world. So one of the key entities would be, as you can imagine, something like cargo or voyage or itinerary. These are the primary entities in the Cargo Tracker object, and these are all nouns. These all have analogs in real world in things in the real world. Similarly, one key thing to understand is entities are not really just about, now some of you from JPA might think this, but don't think this way. So entities are not just about data, right? They're not just a representation of a database table. It's much more than that, because entities are not only supposed to model state but also behavior. So there will be, aside from getters and setters, there will be behavioral methods in entities that actually encapsulate the business logic. A closely related design patterns to entities is value objects. So similar to entities, value objects also model things in the real world. These are nouns. But the critical distinction is that value objects are in a way help you realize the encapsulation value of object orientation. So I'll give you an example, a convenient example. Let's say you have an HR system and employee is an entity. It makes sense for employee to be an entity in that system. But within that employee object, there's also address data. Well, you can put in address data as direct fields in your employee object, but that's not good object-oriented modeling. What you would want instead is a contained object called address that has all those address fields in it. Now, this address object itself does not need an identity of its own. It can simply be attached to an employee object. So that is what a value object actually is. It is a thing just like an entity, but the distinction between an entity and a value object is that a value object is really there to help you construct a better domain model, but it does not have an identity of its own. It does not need one. In terms of database technology, basically it wouldn't have a primary key, whereas an entity would have a primary key. Another closely related concept that is important to understand in domain-driven design is aggregates. So let's imagine for a moment that you've designed your system and it's a well-designed system, and there's a number of databases in your database to store your data. What you will tend to notice is that some database tables are more related to each other than others. So they'll tend to have constraint relationships between them, foreign key relationships defined between them, and the like. This is because when you model a real-life object, some objects are more closely related to each other than they are other parts of the system. Each of these closely related clusters, if you will, form an aggregate. And we'll take a look at this in the example. That's the best way really to understand the concept of an aggregate. But an aggregate is basically a set of closely related entities and value objects. There is an encapsulation relationship here, if you will, as well. In fact, per an aggregate, there will be a single entity that is the aggregate entity, the most important entity in that aggregate. The next design pattern to understand is repository, and I think this is a familiar one to many of you. This is basically DAOs in J2E blueprints parlance. So the purpose of the repository is really, as its name implies, basically to act as an interface between the underlying data storage technology and the object model. So if you want to retrieve an entity, you query the repository. If you want to save an entity, you query the repository. If you want to delete an entity, you tell the repository to delete that entity from the underlying data store. So it's really nothing much more than, in terms of J2E parlance, a session facade of sorts, right? But it's a specialized session facade. That's why it's called a DAO, or data access object, in J2E design patterns. The principal difference in repositories, though, is that typically there is a one-to-one mapping between a repository and an aggregate, rather than a repository and an entity and a value object. So there tends to be fewer repositories in domain-driven design-based systems because the abstraction layer is to the aggregate rather than a specific database table. The next design pattern we'll talk about is a factory. So a factory is, again, in the Gang of Four design patterns, this is a creational object. So in most cases, entities and value objects, you can simply create them using a constructor or simply some setters, and that's all. That's all you need to do in order to construct a new entity or a value object. But in certain cases, some objects are simply too complex, and they involve a bit of business logic, even for the creation step. And that is why factories exist. The factories essentially encapsulate that logic of creating a non-trivial entity, or in most cases, a non-trivial aggregate entity is the most likely case. And there are, again, examples of this in the cargo tracker application that you can take a look at as to how these things should be implemented. The next one is services, and this is a bit tricky because the moment I say services, most of you probably are thinking either RESTful services or SOAP services or something else like that. But there is an analog to those things in domain-driven design. We'll talk about that in a moment, but this is not it. This is what is called a domain service. So what is a domain service specifically? Now, as you probably can imagine, a domain model for the most part consists of entities and value objects, probably most likely a bunch of entities. These are the things in your real world domain that you are modeling, and they certainly deserve to be a first-class citizen. The issue is that there are certain actions or verbs rather than nouns that are important enough in a domain to be at a peer level of entities rather than simply be modeled as a method or a behavior within an entity. I'll give you an example. In Cargo Tracker, essentially routing is a very, very important thing to be doing. Any kind of logistical system, routing is an important thing to be doing. So that deserves to be a service on its own right. And it acts upon other entities, acts upon voyages and cargo, but it itself actually is a top-level domain object. Similarly, if you were to do an insurance-based system, underwriting is a very important verb. So that will probably something that will be encapsulated as a domain service as well. And of course, there is an example of a domain service in Cargo Tracker. So other than these a small number of key design patterns, there are a few other things to understand in terms of domain-driven design. These are things like model-driven development, layered architectures, and a smart UI. I won't cover all of them, but the one thing that you absolutely should understand is layering architectures. So fundamentally layering is not required, not an absolutely mandated part of domain-driven design. You can do domain-driven design without introducing layers. And I have seen such systems. What tends to happen in these systems is that you get a bunch of very long, complicated, more or less controller objects as part of your MVC architecture that do a whole bunch of things, and sometimes are many thousands of lines long because they're dealing with the number of concerns, data access, some interface-driven development, infrastructure concerns, and so on and so forth. Now, the reality in most enterprise systems is that you actually can fundamentally separate some concerns. There are some concerns that are recurring. And if you separate those concerns out into their own layers, you actually will wind up not having these long, complicated objects. And what you will have is much more narrow objects with small amounts of code in them because they're specialized. They do a specialized thing. So we'll take a look at these layers. This is another diagram, again, that is out there in the DDD community. It is also part of the Cargo Tracker documentation. I'll show you that in a moment, so you can refer to it later. So the domain layer is the stuff that we talked about before. Entities, value objects, factories, repositories, those all belong in the domain layer, and they constitute the core part of your application or your domain model. One step above that is the application. So there's a domain model, but then there is primary use cases in the application. So if you will, the meta verbs, the stuff that the application does, that actually can warrant being in its own layer as well. And what the application layer typically tends to do is it tends to coordinate between different domain objects and repositories. And there is an example of an application tier object in the Cargo Tracker example. You can take a look at that. And then there's the interface layer. And the interface layer is basically things like UIs, those RESTful services, or SOAP-based services, if that's what you happen to be using, messaging interfaces. Its whole purpose is to communicate out to something else other than the core of the application, either a human or another system, if you will. And they do things like translating from one data type to the other, doing serialization and deserialization, doing some assembling. These are all of the concerns that we'll see in a moment. These are more to, there's some analog to this in another concept called a bounded context. But that's that type of work. It's usually just mapping things from one to the other, converting things from one to the other. That's what an interface layer typically does. Now, in addition to all this stuff, there is another concern called infrastructure level concerns. And these are things like transactions, data access, asynchrony. These are more frameworky things, if you will. So these frameworky things can actually reside in their own specialized objects and their own specialized cross-cutting layer as well. And what happens is each of the other layers can consume infrastructure as it sees fit. This fits the Jakarta model very, very well, because typically infrastructure concerns in Java EE are either very specialized APIs like JPA or Java Mail, or they are even better, usually annotations of some kind, like the typical annotations that are in CDI or EJB. They fall under this category. And basically what you do is you apply those things, you pepper those things into whatever layer that you need to. But it is in its own thing, if you will. If you write any kind of AOP, or interceptors. That's probably most likely those are infrastructure concerns. You're probably doing some logging or performance analysis or something else of that nature. So that's all about interfaces, applications, and domain. So the one thing that I will note for you is that notice that layers are not mandatory. So even in my diagram here, there is a case where there is a direct interface invocation into the domain layer, and that is also perfectly fine. You do not need an application layer always. If it doesn't add value, you can just directly invoke your domain object from your interfaces. And the cargo tracker example has both cases modeled, so you can take a look at how it differs, and it is similar. These two types of doing things, if you will. All right, so let's begin to map the concepts of domain-driven design and Jakarta EE more concretely. So here's a convenient mapping. Typically, because of those factors that I talked about in Jakarta EE before, there's a relatively clean mapping that does not overlap too much. So interfaces tends to be things like formerly JSF, now Faces, JAX-RS or Jakarta REST, WebSocket, Batch. These are all, again, they function as interfaces to different other things and not the core part of your system. Applications are typically very well modeled as EJBs. The reason is, as I mentioned before, applications are application layer objects or methods typically are use cases or units of work in your application. So that is a very good place to logically apply things like transaction boundaries using the @transactional annotation or just EJB transactions, or security or asynchrony or scheduling. These are good places to apply those concerns. So typically your application objects will be EJBs. That is in fact the case in Cargo Tracker. You don't have to do that. You can use CDI instead if you so wish, and you can use interceptors like @transactional and maybe more in the future as we go along with Jakarta E10 and 11. Entities usually have a pretty clean mapping to Jakarta E. Entities are typically JPA entities, almost a direct mapping. So it models both state and behavior, and we'll see that in the application also. Again, value objects have a pretty clean mapping as well. They tend to be embeddable objects. Some cases it's convenient to still map value objects as entities, just as a infrastructure level concern. It doesn't change the fact that they are in fact functioning as value objects. But in the typical case, and that is the case in Cargo Tracker, a value object will typically just be an embeddable. Infrastructure, again, all those nice APIs in Jakarta EE that deal with infrastructure specifically, right? So this is JPA, Java Mail, Jakarta Messaging. These are all typically infrastructure level concerns, and there's a number of those in use in Cargo Tracker, and you can take a look at an example of all of those also. And then finally, there's a repository. These will be part of the domain object. Typically, they will be defined in terms of JPA or CDI. In fact, if you're using something like Delta Spike data module, the entire repository is just an interface, just an annotated interface, and that's all. All of the underlying JPA code is typically generated behind the scenes for you, so you don't even have to worry about that. All right, so before I move on to more concretely showing you the application and showing you the code, there's one more concept that I did want to talk about in terms of domain-driven design that is worthy of understanding, and it is implemented in the application, and that is bounded context. So bounded context maps to essentially subsystems. All non-trivial systems typically are broken down into subsystems. Even in a monolithic application, you can have a modular monolithic application that has these bounded contexts. And certainly that is absolutely in microservices, there's a case for bounded context as well. So the way to understand bounded context is, let's say you have a key entity called, let's say in an insurance-based application, a policyholder. That policyholder object will actually have different behavior and different bits of data depending on which subsystem it is in. So it'll look very different to a salesperson versus somebody who is doing billing versus somebody who is doing customer service. They're going to want to look at different types of policyholder information that is relevant for that particular subsystem or use case, and the behaviors of what can be done to this policyholder will also significantly change depending on what subsystem that it is in. These are all legitimate domains of their own right. They're sort of mini domains in your application. And in this diagram, which is again also well understood, each bounded context, or if you will, a microservice in the extreme case, communicate with each other using certain paradigms. And you can take a look at and understand the details of all of these things. It could be at the extreme end, the big ball of mud, where you're dealing with a legacy system, or something like shared kernel or open host or separate ways or what have you. These are different ways of dealing with how do you communicate from one subsystem to the other. All right, so that brings us to the cargo tracker application. The URL is embedded in the slide deck. I will now show you, give you a brief tour of the application, the website itself for the application, and show you a little bit of what is there, and then also give you a brief tour of the code. And fortunately, I can do that without IDE, without command line, without anything else, and I'll tell you in a moment why that is. So here's the application. Or rather, here's the main website for Cargo Tracker. So it has a bunch of useful resources in there. Basically, there's an overview that covers much of the same stuff that I told you about towards the beginning of the presentation. There's the goals and non-goals of our project. There is getting started code, so you can download this code, download this repository, and get it started and running in your own local environment very, very easily. Provided you have a Java environment, all you need to do is run this Maven command that you see on screen at the moment. It's a mvn clean package cargo run, and that's it. It'll get your application up and running. You can also get it running in your IDE. You just need Payara, which is the app server we use at the moment. And also you need some kind of Maven capable IDE. Most likely you want to be using something like Eclipse or IntelliJ. So that's how you get started with the application. Now you don't actually have to install anything in your locally on your laptop if you don't want to. In fact, I'm going to show you how not to do that. So the entire application is actually running up on the cloud right at this moment. It's running on a Kubernetes cluster. I'll show you a GitHub Actions. So there's a nightly deployment that happens of the application. So it is running on that Kubernetes cluster, and that is publicly available. So you can go and take a look at the application without even deploying anything, and that's in fact what we are going to do. There's a background information. There's a nice little graphic that explains again the evolution of going from the J2E pet store to the cargo tracker application today. There's an explanation of the basic concepts of domain-driven design and how it maps to Jakarta E concepts. And there's also a section that talks about what are all the Jakarta E features that the application uses. We're not really a Jakarta E demo application, but we do use a fair amount of Jakarta E technologies. There's also a nice documentation section you can take a look at. So there's good things like explaining to you the basic concepts of domain-driven design in Jakarta E. So again, sort of the same concepts that we talked about previously. More details about characterization. Okay, so taking each of the design patterns in Jakarta E and see how they map to in Cargo Tracker. So an example of an entity is cargo. Okay, we'll see that. I'll show you that in a moment, right from here or from the GitHub repo. There's an example of a value object. So leg is an example of a value object, and it's explained why that is. Domain events, aggregates. So this was the cargo aggregate that is mapped for you in a UML diagram, and explained as to how it maps to domain-driven design. There's an examples of repositories, examples of factories, handling event factory being an example. Example of domain services, as we talked about, routing services is one of the key verbs in our domain, and then application services and the like. There's also an explanation of layering, okay, that you can take a look at. Again, that's that diagram there, and it explains to you how each of the layering is working in the Cargo Tracker application. And in general, the concept of layering is explained here as well, including the question of answering are layers actually mandatory. So let's take a quick look at the application, then we're going to dive into the code in the remaining time that we have. So here's the application up and running. As you can see, it is on the cloud, running on a Kubernetes cluster again. Behind the scenes, I'll show you the actions. So this is the nightly actions that are deploying this application to the public Kubernetes cluster. There's several interfaces to the application. As I talked about before, the application is just tracking shipments of cargo across the globe. So there's a public tracking interface. You can take a look at the current status of cargo here. It'll tell you where the cargo is, where it has been, what the handling history is, and a map of what the history of that cargo handling is. There's an administrative interface that gives you a dashboard of all of the cargo that is in the system currently. There's also a live map version of this, so you can take a look at the details of each cargo and where its current status is. As I said, this is live. So this, as changes happen in the system, this map is actually updated in real time without a refresh or anything. You can take a look at, do things like take a look at the details of cargo. You can book new cargo here as well. So we won't go through this, I don't think. And you can also do things like route cargo. So if you have a cargo that is booked, you can go ahead and route it, and it'll give you what all the route options are for a given cargo and the available voyages in the system. So as you can see, in this case, there are 4 different options that I could select to and commit my cargo to a particular itinerary. There is also a event logger interface that allows you to say, hey, what do you want to do, changing the state of cargo. So you could say, hey, I want this cargo loaded or unloaded or what have you, or claimed in a particular port, and this is what changes the state. This is that's will run the state machine of the domain for you, if you will. So let's begin to take a look at the code behind the application. So that is I think the easy way to do that is just browsing it through GitHub. Let me make sure I have the font set appropriately. I think I do. So here's a source code. There's Java. This is the main Java object model that I have. As you can see, there are 2 different. This is a representation of the bounded context. There's 2 of them, Pathfinder and Cargo Tracker. Cargo Tracker being the primary one. Going into Cargo Tracker, as you can see, the package structure of the application models domain-driven design effectively, right? So as you can see, there is the application layer code, domain layer code, infrastructure layer code, interface layer code. In the interface layer code, you will have various things like each mapping the different interfaces in the application. So there's the booking application, the handling application, the tracking application, and the like. So let's take a look at the handling. There'll be a file-based batch processing interface, a mobile interface that you saw, and then a RESTful interface. So these are all mapped in the application. We'll take a look at, let's take a closer look at the application layer. So in the application layer, one of the key objects are the booking service. Okay, so as you can see, this is an implementation of EJB. I'll show you that in a moment. But basically, this is the primary use cases in the application. So booking new cargo, requesting possible routes for a cargo, assigning a cargo to a route, changing destination, changing the deadline. So if you look at the implementation of this, it is an EJB. And if you look at implementation of each of these things, they basically, as a good representation is, for example, let's say assigning route to a cargo. So this is basically looking up the cargo from using the repository interface, assigning the route to the cargo, but there is no business logic in the application layer. The business logic actually resides in the entity itself. So it's making an invocation onto the cargo object's business method, and then storing the cargo out in the repository. So it's a way of encapsulating different parts of the repository, basically. Booking new cargo is another example. Creating a tracking ID, creating a location entity, create another location entity for the destination, creating a route specification, creating the actual cargo and the like. So its job is coordination. So let's take a quick look at the domain model itself. So if you look at the domain, there are several parts of it. There's a model itself. There's a service. So there is the routing service that we talked about before. You can take a look at an implementation of that. If you look at the model, it represents the aggregates in the system. Okay, so there's the cargo aggregate, the handling aggregate, the location aggregate, and the voyage aggregate. The cargo aggregate, as you can imagine, is the main one. Okay, so the aggregate entity there is cargo, but there's a number of other objects that are part of this aggregate. Right, so there's a delivery, itinerary, leg, route specification, all of these things. Similarly, if you look at the voyage aggregate, okay, the key entity there is voyage, but it has a number of other things that are helping that part of the domain model. So these are your aggregates in action. Let's take a look at the cargo entity. Okay, so the cargo entity, as you can imagine, is a JPA entity. Okay, there's the JPA entity annotation. There's behavior, okay, and state. So tracking ID, origin, route specification, delivery. This is all data. But there's also behavior. Okay, so those are the setters and getters. But there's a specify new route, assign new route. Again, this is mapping the behavior of this object. Deriving delivery progress. This is all business methods. And as you can see at the very beginning of this object, there are also embeddables. Okay, so for example, delivery here, okay, is a key embeddable. Okay, this is not an entity on its own. So if you look at the delivery object, it is in fact a value object that has an embeddable in it. There's a lot of business logic in the delivery object, as you'll see when you begin to take a look. But nonetheless, this is a value object. It's a very important value object that is part of the entity model. Let's go back up a second and take a quick look at the infrastructure layer. So as you can see, there's various parts of the infrastructure layer. All of the implementations of the repositories actually reside in the persistence infrastructure. So here's an example. Okay, as you can see, this is primarily just a bunch of JPA code, a bunch of JPQL, but it is part of the infrastructure and it is encapsulated on its own. Another good example is things like logging. Okay, so here's a logger producer that is used all across the application in different layers, but it is encapsulated into its own layer also, and it is encapsulated into its own object as part of the infrastructure layer. So that is it in terms of a quick run through of the code. Hopefully you'll explore it a bit more on your own. I do want to wrap up. I think this is a good enough introduction for now. So again, DDD is a great architectural blueprint for Java applications. Jakarta EE is a very good fit for DDD. I would say one of the better fits for DDD out there in terms of technology sets. And in order for you to see that, you can take a look at that at the Cargo Tracker application as an example of how all of those things actually are put together. So here's some resources for you before I finish up here. Obviously, there's a Cargo Tracker website, and then I've included a number of resources for domain-driven design on its own. Most of these resources are free. You don't have to pay anything. Certainly the one from DZone and InfoQ, those are free. And that will help you learn more about domain-driven design beyond what I have the bandwidth to tell you about today. And if you want to learn more about Jakarta EE, there's a few sister projects to Cargo Tracker to do that, namely the tutorial and the Jakarta EE examples that I certainly welcome you to take a look at those resources. They're very good resources to begin learning Jakarta EE on its own. I thank you very much for your time, and I hope you will check out Cargo Tracker in more detail and ask me any questions on the forum. There is a forum link on the website, and I hope to hear from you.